Hello, in this video we're going to make a footprint from scratch for a standard mail header. Okay, now the tricky thing about the mail header connectors is one, they don't give you the footprints, and then two, you have to pay attention to the recommended hole sizes. I'll be doing this in OrCAD 16.6. The process is similar in other versions of OrCAD, so let's get started. First of all, go to the PCB editor in OrCAD. So let's get that started. Alright, with PCB editor open, go to File, New, Package Symbol Wizard. And I'm going to give it the name of this thing. This is supposed to be a 9-position connector. Wow, alright. Paste this. What name am I using? It's block con or block connector. And actually, maybe I should take out the block BLK. But anyhow, connector 100. 100 refers to the pitch between the two pins. What's the pitch? That's the distance from here to here, or from here to here, pin tip to pin tip center. All right. V is for vertical. Let's see here. 1 square. There are other things on here, but I'm not exactly sure what they mean. All right, so go ahead, click OK. Then, are we using a dual inline package? Is this a SOIC? No, actually it's a single inline package. So let's click next. Load template. Now, is it actually a single inline package? I guess so, but we're just using that to make the process easier. Now, what units do I choose? I will go with inches because that's the primary unit of my data sheet. Then the reference designator will be J because headers and connectors and whatnot are have the standard reference designator as J. 9 pins on this device. The lead pitch, as we saw, is 0.1 inches, 0.100 to be exact. Package width E is from the long end to the long end, so that's that thing. Let's see. If you look at the top here, we're getting information from this, like the actual package, so 0.1 inches, that's fine. We could even go a little bit more on it, honestly. But this is what the datasheet says, so we'll go with it. Package length D is supposed to be whatever A is. Now, A's dimension is equal to, if we look here, alright, it looks like it would be this because of the manufacturer part number, C009S. Alright, A would be 0.8 inches. Hit tab. Next, hit next. Default pad stack to use for simple pins. This is where we'd open pad designer. So go to your Windows Start menu, choose Cadence, choose Pad Designer. I'm leaving PCB Editor open while I make the pad on the fly. Alright, if you haven't seen these techniques before or whatnot, this is actually in my Footprints Fundamentals Mastery class, which is a part of my Pro Hardware Engineer, Pro PCB Designer Bootcamp. Please feel free to message me about it. It'll take you from 0 to junior level PCB designer in 3 to 4 months, using a new innovative way to teach printed circuit board design from scratch. Alright, continuing on, if we go with inches, because the datasheet is in inches, we're looking at the drill slot hole type. It's a circular hole The plating, it is copper plated. The drill diameter needs to be whatever the datasheet recommends, recommended PCB layout. The hole needs to be 39 mils or 0.039 inches. Hit tab. The tolerance, I would go up on the tolerance, so maybe by 0.02 of an inch. The drill figure or symbol, I'll make it a cross, and then this can be something like a letter C or something, I don't know. And then the width of the cross would be the same width as the drill diameter. And the same height too. Now let's go to our layers. This is the hole that I created, but we need to define the copper, how it's going to look. On the top copper layer, the internal copper layers, and the bottom. So let's go to geometry circle. The width of the circular pad is supposed to be at least 0.020 inches greater than the drill diameter. So if the drill diameter is 0.039, we need to add 0.02 and get 0.059. Hit tab. Now we're looking at the cross section here. This green is the hollow hole part and the red is the copper. I am tempted to even go greater on this. Let's go 0.60, you know. Actually, let's keep it simple. 20 mils greater, 20 mils greater. So, all right. The height automatically is updated because a circle is supposed to have the same width and height. For this here, we're going to go with thermal relief. The thermal relief needs to be at least 20 mils greater than the pad. So let's choose circle. And that'll be 79 thousandths of an inch. Copy this value. And then for the anti-pad, we'll make this circle as well. Hit tab. Now, for the begin layer, we'll right-click, copy to all, solder mask, paste mask, click OK. And this looks good. Our manufacturers tend to want our solder mask top and bottom and whatnot to match, oh, and also the paste mask top and bottom, to match the dimensions of the copper pad nowadays. For this one, paste mask, I don't think I'll have paste mask on the through hole device. I don't want that. Surface mount, yes, but not through hole. Alright, this is the cross section. The green is the cross section of the hole that we can see through. The blue pad is the begin layer. It's highlighted in red to let us know which one we've selected and so on and so forth. Okay, from the top, this looks like a hole. The copper on the top, which is yellow, and the hole, which is like a sort of grayish off-white. Let's go right-click, save as. Let's use a naming convention for the pads. This would be pad, and then we'll choose the diameter in mils. The diameter in mils is of the copper pad is actually 59 mils. It's circular, and the drill hole is 39 mils in width, and drill, D for drill. Let's go to our default symbols folder, local disk C, OrCAD, share, PCB, PC_ library symbols, and we save it in here. But before we save it, copy the name of the pad. Click save. Save. Let's minimize this. Click on the ellipses. Paste the name of the pad, hit tab. See the pad stack is already in there automatically. Click OK. Click, that's another thing. I did all circular, but I need to make a new pad that has a square shape around it. So let's go back to the pad stack editor. We're going to make a new pad stack by modifying this existing one. The hole type will be a circular drill. The plating will be plated, that's fine. But for the layers, instead of a circular copper regular pad. We're going to go with a square pad to indicate pin number 1. This is how it looks from the top. Doesn't look different on a cross section. Thermal relief, you can, sure, let's make it square. Why not? It'll be kind of strange, but hey. Right click, copy to all, solder mask. Click OK. Great. Now, the default internal doesn't need to be square or anything, but I'll leave it like that out of laziness. Go to File, Save As. And in this one, we are already in the symbols folder. If you don't know which folder that is, OrCAD, OrCAD, share, PCB underscore lib symbols. And then for this one, we need to give it a different footprint name. Maybe square, SQ, sure. Double click, copy this name, save. Minimize pad designer. Click on our ellipses for pin number 1. Control V, paste. See, it shows up in the list. Click OK. Make sure that whenever you're searching for it, their asterisk comes at the end too. Click OK. Hit next. Select the location of symbol origin. The symbol origin for through-hole devices, according to IPC standards, is pin 1 of the symbol. For surface mount devices, it would be the center of body, center of mass or something for the device. Typically the center, but not always. Select whether or not you want the package wizard to generate a compile symbol, PSM for you. Create a compile symbol, yes. Hit next, hit finish. Fantastic. Now, mine doesn't show. I've got a little bit of a glitchiness on my 16.6, so let's highlight. There we go. Now it shows up. I need to make some modifications to this though. So let's go to Setup, Design Parameters. I want some more space to work with. Go to Design, A, Apply, click OK. Now my grid is too big. It's really large. What I can do is hit my move thing, and I don't like my part being all the way in the lower left here. Let's hit move this over to there. The problem with doing this is that my origin is still where it's at, right? So I'm going to move my origin now. Go to Setup, change our origin, or change drawing origin. Then you want to right click on that pad, snap pick to, choose pin, boom, drawing origin has been changed. Next, let's select everything, right click on some kind of edge or something of the actual footprint, choose line, change width. Our default line widths for silkscreen and assembly and all that stuff are usually 0 line width, which is a problem when we're trying to generate drawings and silkscreen film layers. So we want to set this to the IPC, within IPC standard range and thicknesses for silkscreen, which would be 4 to 6 mils thick. What is a mil? It's a thousandth of an inch. Now I think I'm in inches in this design, am I? Or am I in mils? Let's find out. Hit 5, hit OK. Okay, let's see. My setup design parameters, I'm in inches, so it can't be 5 inches. Let's try this again then. Right click. I will highlight everything, right click, line, change width. And it'll be 0.005 inches. Now the line thickness has changed, and that's my silkscreen and assembly. Now the thing here though is that if I right click and move this thing, my silkscreen underneath there is hidden. If I try to place this device, I don't know if the silkscreen will show up on the PCB after I put the device on the PCB. So what you want to do is add an extra line somewhere. You could delete the silkscreen line or whatnot. If you don't know how to do it, you can message me. I'm not going to do all that. It's too much work. The footprint is pretty much done. So let's go ahead and go to Setup, Design Parameters, Text, setup text size is photo width 0.05 or 0.005. Copy and paste that into text. Block sizes 3, 4, 5, 6, however many you want. Click OK. Apply, then OK. But you know what? I will at least pretend like I deleted the underlying silk screen below there, and I'll just show you how to add a silk screen. So right click, you quick utilities, change your grid size to be finer. And we're going to make it 0.010 inches or 10 thousandths of an inch. Click OK. Now when I zoom in, I could start adding my line for a silk screen. Click Add Line, Package Geometry, Silk Screen Top. Set the line lock to 90 degrees and the line width to be 0.005 inches. Now I can start drawing my, let me see, this is supposed to be the thing. This is supposed to be the extent of the device package, so let's draw outside of that. Let's go down some more here. Oh wow. Okay. Right click, choose done. I don't like the grid, so quick utilities, grids, turn that off. Click OK. Control S to save the footprint. Yes to overwrite. Now that's a decent looking footprint, right? If we do the 3D canvas, it looks like a block though with the holes on there. So you know what? I will add a step package mapping to this. Where is my step package? It is this, I believe it is. So we right click. All right, this takes on the manufacturer name, manufacturer part number, excuse me. So local disk OrCAD Lite. I'm copying this and I'm going to paste it in my default step model folder. Share local PCB step, right click, paste. This is what I'll look for, pre C000. Alright, so go to setup in the footprint manager or whatever this is, PCB editor. Then choose step package mapping. Now select it. Now it's oriented weirdly, so I need to rotate this 90 degrees, rotate this header 90 degrees above the x-axis. Let's go and do that. 90, enter. And I love to overlay the footprint. Okay, see what's going on here. The package and the holes itself, they're not aligned. It's off by 90 degrees in the Z axis. So let's go 90Z. Okay, let's do 180Z. Nope, you'd think I would do 70. Great. Now, if we look at the front of the footprint, here's what we look at. Now you can use the right mouse button to drag this down. And let's see here, let's get the front. What does the back look like? Okay. What does the left look like? All right. Let's look at the bottom. Always check the bottom. See if the pins align. Use the right mouse button. See, now you can make a little minor adjustments here. Let's go ahead and look at the arrow key increments. This would be in inches. Let's reduce that to say 0.001 inches. Use little arrow keys to increment that. Make sure it's dead in the center. All right. Okay. Nowadays, I always use this. I always get the 3D models. You know, when you're doing the footprints, you gotta get the 3D models. So click Save. Go back to a front left or front right kind of isometric view there. Looks nice. hit save again, close. Make sure you save often. Then look at the 3D view. And wow, this looks, it's kind of weird on my graphics there, but hey, I'm sure it'll look better on yours. My machine is like 6 years old. Alright, go ahead and close that. Now that that's finally out the way, we can see that if we use the same name for this footprint, right? So I don't think I changed the name from BlockCon. That means this is for part number J5 in my design. When I click on here, right click, show footprint, since the footprint is in the default folder, it should show up. Fantastic. And look at how the pin numbers match. See how they match the pins and names of the footprint pin name? Fantastic. And you can rotate that real time. Look at that. And then it also shows you the folder where the footprint is saved. Alright, go ahead and save your design. Thank you for watching this video. This is how you get and download, well, this is how you create a footprint from scratch and get a 3D model. Oh, right. How do you actually get the 3D model? You can get it from many places. DigiKey is really good about that, getting at least the 3D models, but this is when you can't find, like, say, the footprint on Ultra Librarian or Samaxis or DigiKey or anywhere. You have to make it from scratch and use the datasheet to create that footprint. Always use the recommended PCB layout for the holds, and also use information from the part itself, from the datasheet. This will save you so much time if you do the parts and footprints properly the right time, the first time. Because if you make mistakes and you get the PCB layout and send it to the manufacturer, they're going to ask you to fix it anyway. And if they don't ask you to fix it, you might have boards that can't fit certain parts, and you have to throw the boards away. Alright, thank you for watching and have a good one.